IFT's high-yield course is based on Pareto's 80-20 rule. According to this rule, 80% of your exam is based on 20% of the curriculum. IFT's high-yield course focuses on 20% of the curriculum. So why do we call this the high-yield course? The investment here is your time, and the time you will need to spend is relatively low. The return is exam success, and when you do the high-yield course, the probability of passing the exam is high. So in that context, this is a high-yield or a high-return course. But as with any high-yield investment, there is also risk that you need to be aware of. So if you are time constrained, then the high-yield course makes a lot of sense. On the other hand, if you do have time, then I would recommend that you do the regular course and then cover the high-yield material towards the end as part of your final review. The high-yield course has 3 components: high-yield lectures, high-yield notes, and the high-yield Q-bank. With the high-yield lectures, we spend an average of 15 minutes per reading. Here we focus on the most important concepts. We do not give detailed explanations. What we do here is largely read from the high-yield notes. So in that sense, the high-yield lectures are closely linked with the high-yield notes. Those who prefer reading rather than listening to lectures can simply go over the high-yield notes. Here we have the same points as the lectures. There is just a little more detail, plus we also have a few more worked examples. And then we have the high-yield question bank. The high-yield question bank covers the most testable concepts from each reading. It follows the learning outcomes, and there is minimum overlap between questions. The high-yield course will be released topic by topic, starting with quantitative methods. For details, please click on this link. That is it, and best of luck with your studies.
Time value of money. Interest rates can be interpreted as a required rate of return, a discount rate, or an opportunity cost. Let's say you invest $100 today and you require $110 at the end of 1 year. In this case, the return that you are requiring is 10%, and that is one interpretation of interest rates. We can also say that interest rates represent a discount rate. So if we take $110 after year 1 and discount this back at 10%, then we get 100. So therefore 10% is also a discount rate. Interest rates can also be thought of as an opportunity cost, because if you spend these $100 today, then you give up a 10% return. Components of interest rates. Interest rates can be thought of as a sum of these components: the real risk-free rate, the inflation premium. Here the inflation premium is the expected inflation. Then we have a default risk premium. This is a premium that we add because of the risk of default. Liquidity premium is a premium we add if the security that we are talking about cannot be sold very easily. And then maturity premium is a premium based on the maturity of a security. Investors prefer short-term securities to long-term securities. There is greater risk associated with longer-term securities, and that's why we add a maturity premium. Now, to understand this, let's say a company issues a bond and the country where this company operates has a real risk-free rate of 4%. Let's say the expected inflation over the upcoming year is 3%. The default risk premium is 2%. So this is a premium associated with the risk of default. Let's say that this bond cannot be bought and sold very easily. So we have a liquidity premium of 1%. And this is a 5-year bond. So we have a maturity premium. And let's just say that that maturity premium is 1%. If we have all these numbers, then the relevant interest rate for this bond will be 11%. Stated rate, effective annual rate, and frequency of compounding. Let's say we have a certificate of deposit where the stated annual rate is 12% and the frequency of compounding is 2. So generally in this formula, the frequency of compounding is denoted by M. This means that interest will be calculated 2 times a year. In other words, every 6 months. To calculate the effective annual rate, this is the rate that we are effectively getting over a 1-year period. We use the formula shown here. So the effective annual rate with this example is going to be 1 plus the stated annual rate of 12% divided by the number of periods. So this essentially becomes 0.12, which is 12% over 2. So we have a 6% rate over a 6-month period. And then this needs to be raised to 2 because we have 2 periods in a year, and then we subtract 1. If we do this calculation, we will get 12.36%. If we have quarterly compounding, then M becomes 4. If we have monthly compounding, then M becomes 12. If we have continuous compounding, then we need to use this formula. So we essentially have e to the power of the stated annual rate, which is 12% in our example, and then we subtract 1 and we get 12.75%. Notice that as the frequency of compounding goes up, the effective rate also goes up. Next, we look at future value and present value calculations. Let's start with a single cash flow. Say we have $100 today. The interest rate is 10%. How much will this grow to at the end of 5 years? So this is a future value calculation. One way of doing this is to simply say that the future value is 100 into 1 plus the interest rate, which is 10%. Raised to the power of 5, and this gives us 161.05. We can also use a calculator. So with a calculator we can say that the present value is 100, n is equal to 5, the interest rate is 10%, the payment is 0, and we compute the future value, and that will be this number. With a present value calculation, we have an amount in the future. So let's say at the end of 5 years, we have 161.05, and we want to calculate the present value at time 0. So using a calculator, we can plug an interest rate of 10%, n is equal to 5, future value is 161.05. There are no payments in between, so we set payments to 0, and then when we calculate the present value, we will get 0. Next we come to an ordinary annuity. An annuity is a series of equal cash flows that occur at regular intervals of time. With an ordinary annuity, the cash flow happens at the end of each year. So if we have 5 years and the cash flow is 100, so we have 100 at the end of each year for 5 years. Let's say that our interest rate is 10%. In this case, n is equal to 5. We can say that the payment is 100 and we can then compute the future value. For present value, we'll say it is 0 because there is no cash flow over here. In this case, when we calculate the future value, we'll get 610.51. For this ordinary annuity, we can also compute the present value. Here we'll say that n is 5, interest rate is 10, FV is 0 because there is no payment other than 100 at the end of year 5. When we calculate the present value, we will get 379.08. With an annuity due, the cash flow happens at the start of each period. So if we take the same 5 periods, but we now say that we are dealing with an annuity due, then the payments of 100 basically shift left. So the first payment is happening at the start of period 1, which is the same as time 0. Then we have 100 over here, 100, 100 and 100. So the same 5 payments but shifted to the left. Now the future value is going to be somewhat higher than 610.51 because the payments are being received earlier. If you want to use the calculator to come up with the future value, you have to first put the calculator into begin mode and then you plug in the numbers as before. Also keep in mind that the future value that is being calculated here is at the end of period 5. For the present value calculation, you again make sure that the calculator is in begin mode and then you say that n is equal to 5, interest rate is equal to 10, the future value is 0, the payment is 100 and we compute the present value. And in this case, the answer that you will get is 416.98. Notice that with an annuity due, the present value is higher than what we have with an ordinary annuity, and this is because the payments are being received earlier. With the perpetuity, we get a cash flow every year forever. So if we have a situation where we get $100 at the end of year 1 and then $100 at the end of every year forever. So this is a perpetuity. The present value of a perpetuity is equal to the cash flow or the payment divided by the interest rate. If the interest rate is 10%, then the present value is going to be 100 divided by 10%, which is 100 divided by 0.1. So we have a present value of 1000. Notice that the present value of a perpetuity is 1 period before the first cash flow. And finally, we have uneven cash flows. So let's say that we receive $1,000 at the end of year 1, $2,000 at the end of year 2, and then $3,000 at the end of year 3, $4,000 at the end of year 4, and $5,000 at the end of year 5. So what is the present value? What you do in this situation is take the present value of each of these cash flows and then add the 5 numbers. For the future value of this cash flow, you take each number and compute the future value. So you take 1000, compound this forward 4 periods. Then you take the 2000, compound that forward, compound this forward 2 periods, compound this forward 1 period, and then add all 5 numbers. This 5000 is being received at the end of year 5, so we don't need to compound this. For present value calculations, you take each number and find the present value. So you find the present value of 1000, then the present value of 2000, and so on, and then add all the numbers. Using timelines, we've already introduced the concept of timelines, but I just want to emphasize a particular point here. Suppose you'll receive $100 at the end of year 3, 4, and 5. So in our timeline, this is point 0, which is now. This is 1, which means the end of year 1. This is end of year 2, end of year 3, end of year 4, and end of year 5. So we'll receive $100 here, here, and here. What is the present value at time 0? What we can do here is treat these three numbers as an ordinary annuity. So we can say that n is equal to 3, the interest rate is, let's say, 5% over here, and we come up with the present value. The present value will be 1 period before the first payment. And when we do this calculation, we'll get 272.32. And then this needs to be discounted back 2 periods. So we can then say that this is the future value. The interest rate is 5%, n is equal to 2, payment is 0, and we compute the present value, and that will be 247. Now another question, compute the interest rate given the number of periods, the present value, the payment, and the future value. So let's say that we have 5 periods. We know that the present value is this much. We know that the payment is 100 and the future value is 0. So we are essentially given the fact that there are 5 periods. We know that the payment is 100. So this is an ordinary annuity. To come up with the interest rate, we say that n is equal to 5. So n is 5. We plug in the present value, which is 379.08. But then when we plug in the payment, we need to make this a negative number, because we are calculating the interest rate, which is going to make the present value of these 5 payments equal to 379.08. So you plug in payment is equal to 100 and then hit the plus minus sign. So that makes the payment minus 100. You set FV equal to 0 and compute the interest rate, and you will get 9.999, and this effectively is 10%. So that is it for this reading.